So how do these two quantities of distance and displacement refer to those two categories we just covered of scalar and vector? Well, when we think about distance, right, we know that both of these two things are describing how an object's position changes. What our distance is measuring for us is what we call like the total amount of ground that an object has covered, as again its position changing. So with this, typically what we do, again, to represent distance with a lowercase d, is that we want to know if an object is traveling through multiple legs, right? What is the total amount of all those legs added together? So for this, we say that the path our object takes matters, right? So we want to know how does each individual leg get us from our starting point to our ending point. Now distance, right, this is going to be one of our scalar quantities. So typically we have no direction involved in measuring our distance, right? We're not care where we're traveling. All we're caring is that we're actually moving and covering some amount of ground. Displacement, though, tells us our change in our position from our starting point to our ending point. And again, we use this kind of delta x to represent displacement. So with displacement, we said that the path our object does not matter, right? The only thing that matters is the starting point and the ending point. And again, because our displacement is going to be a vector quantity, means that the direction is important. So just to kind of highlight the distinction between distance and displacement. All right, let's say we have an object that's moving from point A and it's going to point B. Now there's basically like an infinite number of ways that we can actually get from point A to point B. Right, the one that's probably most familiar to us, the most direct, is we can just travel a straight line path going from A to B. Right, that's option number one. Option number two, though, is we could take a little bit more of a roundabout way. Right, maybe we leave point A, we come upwards, and then we make our way over to point B. We have another possible path. Maybe we go around, we do some crazy sort of like loop-to-loop. We're all over the place. We're zigzagging back and forth, and then eventually we end up at point B. So for these, what we would say is that all three paths are going to have the same displacement. And again, they have the same displacement, right, because the starting point and the ending point are the same for all three. So our change in position is going to be the same. All three start at point A, all three end at point B. That change is the same for all three. Our distance traveled, though, is going to be different. So we can say our, again, distances are going to be different, whether we take the black route, the red route, or the blue route. So the one that has the shortest distance, that's just going to be a straight line, A to B, along that black line. And looking here, it looks like our pathway in blue there, that's going to be the one that takes us the greatest amount of distance. So again, when we think about distance, right? We're looking at the total amount of ground that we cover. Right, the reason why we said that the path of the object matters is whether we go along the black line, the red curve, or the blue curve. Right, that's going to depend upon how much total ground we covered in that process.